In this video we have a look at a beautiful problem on Laplace transform. We have this function f of t equals t times exponential at, where t is strictly greater than 0 and also a is a positive parameter. We want to show that the first relation holds. This is a relation associating the function and the derivative of the function f of t and the derivative f prime of t. This is the first thing that we need to show, and then we would like to find the Laplace transform of the function f of t using part A. We start with the first one. We differentiate the function f of t, so we have the derivative of t times the exponential plus t times the derivative of the exponential function. So here we get the derivative of the function of the identity function is 1, so we only have the first term to be the exponential plus t e to the power of a times t times a. So from here we have a times t e to the power of a times t plus exponential at, this one. So we can polish it a little bit. This bit here is my function f of t, and I rewrite the exponential. So what I get is f prime of t equals a f of t plus e to the power of a times t. So I have proved the first question. Now let's go to part B. Before going to part B, I need to find the Laplace transform of f prime. So I take the integral from 0 to infinity f prime e to the minus st dt. So it's f of t e to minus st. I do integration by parts plus s integral from 0 to infinity f of t e to the minus st dt. This is f of s minus f of 0, but f of 0 is 0 e to the power of a times 0 is 0. So this term is vanished, and I have that the Laplace transform of the derivative of the function f is s times the Laplace transform of f of t. Now I go back to this relation here. And I use the Laplace transform on both sides. It's a linear integral operator. It's a linear integral transform. So I will have the Laplace transform of the derivative equals the Laplace transform of the product of a times f of t plus the Laplace transform of e to the power of at. This is s times the Laplace transform of f of t equals a times Laplace transform of f of t plus 1 over s minus a. This is the Laplace transform of the exponential function. Now I get this term to the left hand side, so I will have s Laplace of f of t minus a Laplace of f of t equals 1 divided by s minus a. I take the Laplace transform of f of t common factor, and I have s minus a inside the brackets equals 1 over s minus a. So from here the Laplace of f of t equals 1 over s minus a squared, and s is greater than a. It's a quite nice problem in using the Laplace transform. The first part is to find we find the relationship that associates the derivative of the function and the function, and this helps us then for the second part to find the Laplace transform. We could find the Laplace transform of this function by directly, straightforward, but we would have to do integration by parts, whereas here is a more straightforward way, and this method, this approach here, finding a functional relation and then using the Laplace transform, helps us to avoid using the integration by parts.